Step 2 in our overview for our two-tailed Pearson R, as we know, is to define now our critical R values. We're still doing the same overall job here. We still have to decide how strong of a pattern is strong enough, right? How reliable does that pattern need to be? So to do that, we need a new table. So here was our Q, back here was our F tables, there's our Q tables. The very next table for us, table B.6, is the critical values for the Pearson correlation. So pause your video playback here for a second, go find that page in your book. This page doesn't match your book, so I would tell you. But B.6. Okay, now notice that this table is broken out a little bit like our old T-tables. Two-tailed test and one-tailed test. The first line is for a one-tailed test. The second line is for a two-tailed test. And we can see across our alpha levels. So part of what we need to know is what we've always needed to know. We need to know, are we running this test at 0.05 or 0.01 alpha level? And we need to know if we are running this as a one-tailed test or a two-tailed test. Currently we're working on two tails. So down the side, we are looking for our degrees of freedom. Now if you look at that column very carefully, you can see that the formula is different than we've ever seen before. Typically just straight up degrees of freedom is lowercase n minus 1. But here we have lowercase n minus 2. It's changed on us. There's a very important reason for that. So let's say I'm going to do a correlational study. And the two variables that I'm interested in, one of them is how tall the person is, their height. And the other variable, this says distance to campus. How far do you live from our North Las Vegas campus? And since we're not really doing math per se here, I'm just labeling these values as low, medium, high, right? We know there's number lines here. So I look to one of you and I say, okay, how tall are you? And you reply to me, oh, I am 6'2". So they are very tall. They've got a high value for the height variable. And then I say, okay, and more or less, how many miles is it that you live from where you live, your house to our North Las Vegas CSN campus? And someone says, oh, I live just right around the corner. I live just a half a mile. So they're very low distance. So there's the first student I've interviewed. Remember, just like we saw on the slides, every dot is the intersection of data. This is one person measured both times. Now I go to someone else in the room and I say, okay, great, how tall are you? And the next person tells me, oh, I am 5'6". For a male, that would be just probably a little bit under medium. And I say, okay, cool, but how far do you live from campus? And they say, oh man, I live in, Henderson. I take a drive every day when I go to school. So they live a long way. So that's my second person. And I now stop my study. I'm done. I only wanted a sample size of 2 because apparently I don't know how to do this work. Well, let's think about what I've done here is I've started my scattergram, my scatter plot graph. Well, let's go ahead and put an envelope around it. Let's go ahead and hit it with a trend line. Well, what we know from our scattergram is that this is a perfect relationship. It might surprise you to learn that there is a perfect relationship between how tall you are and how far from campus you live. And generally what we can see is that the taller you are, the closer you live. It's perfect. No exceptions. Both dots are, my handwriting aside, both dots are exactly on the line, right? Okay. but there's only 2 dots. So what this tells us is you can't properly do one of these studies with only 2 people in your sample. Because any 2 dots you put anywhere on a graph, doesn't matter what you call them, label them whatever you want, put any 2 dots down and stop. Guess what? They form a straight line. Any 2 dots forms a straight line every time, right? Sort of the definition of in terms of geometry here. So if we're only working with 2 people, we're always going to come out with what looks like a perfect relationship, a perfect association every time. We need at least one more person to kind of check. So I go into the room and I ask for a 3rd person, and they tell me that they are 5 foot tall and they live 6 miles from campus. Oh, well, there. Oh, well, look at that. We have a person not actually on the line. I have to redraw the envelope. I'd have to redraw the trend line, something closer to that, right? Oh, all of a sudden we're a long way from perfect as soon as we added a 3rd person. So that takes us back to here, n minus 2. So if we start with only 2 people, minus 2 is 0. 0 degrees of freedom, can't do the study. There's no entry for that, not allowed. We have to have at least 1 degree of freedom, which means we have to have at least 3 people. 3 minus 2 gives us 1 degree of freedom. That'd still probably be a pretty lousy quality study, right, with only 3 folks in it. But this way we can ensure that we at least have 3 people in the study. That's why this formula is bumped up to n minus 2. And it says that right on your, right on your tables here. If you look at it again, I know you can't see that on the camera right now, but df equals n minus 2. You don't have to memorize that. You just have to read it, right? So that is our step 2. We get the alpha level. We determine how many tails we're running the test at. We get our degrees of freedom. And then just like before, we just use the correct heading and we find our critical R value. And when we look at the table, we can see that all our answers are written to 3 places. So we know that this is going to come out to 3 places here. So we get our critical R. Don't forget 2 tails. We're back to needing to indicate if it's plus and minus, or just minus. So we know for 2 tails it's both plus and minus. And we record our value here. This is normally going to be, that looks sloppy because it's almost always a 0 in front. And then again, we've got to set up both tails. Maybe we'll have a positive direction in the association. Maybe we'll have a negative direction in the association. So that's step 2. We're going to look at steps 3 and 4 in the next clip.